Morning. Here's the answers to, or the solutions to 6.11 day 1 homework. Again, if you don't need to watch all of them, then don't. Please don't copy my work though. Try these on your own. Feel free to fast forward to any problem that you need help with. All right, when the angle of elevation, start in the beginning. Solve each problem. Okay, show your work. Make sure you read carefully on how to round your answer in each problem. Many are different. If it's not specified, then round to 3 decimal places. So let's look here. When the angle of elevation is 54 degrees, a building casts a shadow that is 23 meters long. To the nearest meter, how tall is the building? All right, angle of elevation to the sun, it's kind of implied there. Angle of elevation to the sun is 54 degrees. So 54 here. All right, the building casts a shadow that is 23 meters long. All right, so here's the shadow on the ground, 23. To the nearest meter, how tall is the building? So this is what we're looking for right here. How tall is that building? All right, so from the 54, there's opposite and adjacent. That's a tangent. So we have tangent of 54 degrees is x over 23. Multiply by 23, and x is 23 tangent 54. Zap that in your calculator. 31.6567. 1.6567. All right, but now let's go back to the nearest meter, to the nearest whole meter. So 31.6, that 6 is going to round up. So your answer here is 32 meters. The building is 32 meters tall to the nearest meter. Next one here. A 5-meter vertical pole casts an 8-meter shadow. So flagpole, 5 meters. Casts an 8-meter shadow. 8-meter shadow. What is the angle of elevation to the nearest degree? All right, here's that angle of elevation in here. Oops, and you know what? It's an angle. I should use an uppercase letter for that because it's an angle. All right, so from this, we have opposite and adjacent. That's a tangent. The tangent of E is opposite 5 over adjacent 8. So E is inverse tangent of 5 over 8. On a calculator, and 32.0053. For this one, I'm just writing a bunch of decimals here, usually 4, and then I'll go back and check my rounding. What is the angle of elevation to the nearest degree? So nearest whole degree, we look at this 0. That 0 does not make this 32 round up, so 32 degrees. All right. Number 3. A kite is flying at an angle of 42 degrees with the ground. All 70 meters of string have been let out. Ignoring the sag in the string, find the height of the kite to the nearest 10 meters. There's no right triangle given in this one, so I have to make it. Here's the string. Okay, a kite is flying at an angle of 42 degrees with the ground. So 42 degrees, because here's the ground down here. All 70 meters of string have been let out, so that's 70. Find the height of the kite to the nearest 10 meters. So height of the kite, I'm going to call that x. From the 42 then, let's set this up. We have opposite and hypotenuse. That's a sine. Sine of 42 is opposite x over hypotenuse 70. So we have x is 70 sine 42. 46.8391. Okay, and what do we want? Find the height of the kite to the nearest 10 meters. So nearest 10. So 46 would be, we got to round that up, that's closer to 50. So the height of the kite to the nearest 10 meters is 50 meters. Looking at this next one, a truck drives up a 30-meter incline. Oh, look at this. They've given us the diagram. The angle that the truck drives up is 23 degrees. Perfect. To the nearest meter, how high vertically did the truck rise? So how high? This high. We'll call that x. Setting this up then from the 23, we have opposite and hypotenuse. That's a sine. Sine of 23 is opposite x over 30. X is 30 sine 23. 11.7219. Okay, to the nearest meter. So nearest whole number, this would round to 12 meters. All right, now, this one's a little bit tricky. So Martha is 66 inches tall and her daughter Heidi is 33 inches tall. Who casts the longer shadow? Martha when the sun is 80 degrees above the horizon, or Heidi when the sun is 40 degrees above the horizon? By how much? So, and then I have a hint, make two separate right triangles, one for Martha and one for Heidi. So here's Martha's. All right. Let's draw the ground here. And there's Martha. Let's do the same thing for Heidi. Okay. Now, Martha is 66 inches tall. So this vertical distance right here, 66. And Heidi is 33 inches tall. Let me put her height in. Heidi's height, 33. Okay. Martha has the sun 80 degrees above the horizon. That's the angle of elevation. So 80 degrees, because here's the horizon, right? Above the horizon, so it's going up. Heidi has the sun 40 degrees above the horizon, so 40. And we want to know who casts the longer shadow. So shadow down here for Martha, let's call that X. Heidi's shadow, let's call that Y. And then let's go ahead and solve for both of them. So from this 80 degrees, we have adjacent and opposite. That's a tangent. Tangent of 80 degrees is 66 over x. So x is 66 divided by the tangent of 80. I'm going to set up Heidi and then I'm going to type them both into the calculator around about the same time so I don't have to keep swapping back and forth. For Heidi, adjacent to opposite, same thing, so a tangent of 40 this time is 33 over y. So y is 33 divided by tangent 40. All right, here we go. Here's Heidi's. 33 divided by tangent 40 is 39.327. 3279, because that 6 made that 8 round up. And Martha's is 11.6375. All right, now let's go back to the question. Which one has the longer shadow, Martha or Heidi? it doesn't tell us decimal places, so then I got to go 3 decimal places here. And I got to use Martha's 11.6375 minus Heidi's 39.3297. So Martha has the longer shadow. By, all right, now I got to subtract these two, and I'm going to use, I'm going to use the big, long, nastiest decimals. Oops, did I just say that? Big, long, nasty decimals, so I don't have to worry about rounding. So I got to do the, oh, did I just say Martha? No, silly. Heidi has the longer shadow. Hers is 39. Ah. Okay, Heidi has the longer shadow, so now I got to do this 39 point whatever mess. I'm going to go back up and grab it, so 39, and then minus the 11 one, this one, and I got 27.690 inches. 27.690 inches. All right. Okay, on to page 27. Number 6. To find the distance from point A on the shore of a lake to point B on the island of the lake. So here's the lake, the shaded part. There's the island right here. Surveyors locate point P with the measure of angle PAB is 62. PAB, 62. And the measure of angle APB, APB is 28. And if PA is 350 meters, find AB, this distance here, X. All right, now, they didn't for sure tell us this was a right triangle, but we can figure that out. Because if you add 28 and 62 together, you get 90, which means there's 90 left for this angle down here at this one. So now we definitely have a right triangle, and we have to find this distance x. Now you can use the 28 or the 62, makes no difference. Since it gave you both numbers in the problem, you're good to go. I think I'm going to use this 28 one. I'll show you why in a moment. So 28 opposite and hypotenuse, that's a sine. Sine of 28 is x over 350. I prefer to have my x in the numerator, so that's why I chose that one. I guess it would work for the 62 as well. It would be x, it would just be cosine. So it doesn't really matter. X is 350 sine 28. And 164.315. X is 164.315. These are meters. And did they tell us to round in anything? No. So that's AB right there. All right, let's look at this one. Miguel looks out from the crown of the Statue of Liberty, approximately 250 feet above ground. He sights a ship coming into New York Harbor and measures the angle of depression is 18 degrees. Find the distance from the base of the statue to the ship to the nearest foot. All right, so we got to draw a triangle on here. Let's see. He's standing up at the crown, and he takes this down to the ship. So crown down to the ship. There. And he measures the angle of depression is 18. All right, we'll get that in a minute. I'm just going to finish drawing out my right triangle. Hopefully you can see this on there. And the horizontal distance, that's what we want. That right there. You know, that's kind of hard to see on there. I'm going to redraw that triangle out here. keeping it the same orientation, I'm going to put it this way, so that we can write on the diagram and actually see the measurements. All right, Statue of Liberty is 250 feet above ground, so that's this distance, 250 feet, so that's over here, 250. He measures the angle of depression is 18 degrees. Now, be careful. 18 is not in here. That's not the angle of depression. The angle of depression is out there. It's how much you have to tip your head down from looking horizontally to looking at the item that you want. So that's 18 degrees, which we know the angle of depression and the angle of elevation are congruent. So I'm going to take that 18 here and put that 18 right down there, because there's the angle of elevation, alternate interior angles. And we want to find the distance from the base of the statue to the ship. Base of the statue to the ship, that's this right here. That's your x. Now if we set this up from the 18, we have opposite and adjacent. Tangent of 18 is 250 over x. X is 250 divided by tangent 18. And we get that 769.4208. And we want to the nearest foot. Nearest foot, so 769, this 4 does not make that 9 round up, so nearest foot would be 769 feet. Okay, next. A fire department's longest ladder is 110 feet long, and the safety regulation states they can use it for rescues up to 100 feet off the ground. What is the maximum safe elevation for the rescue ladder? So, we've got this picture going on down here, and here's this ladder. This ladder is 110 feet long. Maximum height we can go is 100 feet. And you got to kind of extend this triangle a little bit, and then here's the angle of elevation right in there. So we have opposite and hypotenuse, that's a sine. Sine of E is 100 over 110. Inverse sine 100 divided by 110 is 65.380. 65.380. It doesn't tell us what to round, so that's it. It's an angle, so degrees. All right. Not that one. That's day 2. I got a stack here of videos to make. Let's do this one. Last problem for this day. James and Rick buy a tent that has a center pole of 6.25 feet tall. If the sides of the tent are supposed to make a 50-degree angle with the ground, how wide is the tent at the bottom? So, center pole right here is 6.25 feet. Sides of the tent are supposed to make a 50-degree angle, so 50 here. Again, hard to draw on top of there, so let me redraw that triangle out here. So 50 degrees here and 6.25 there. And we want to know how wide the tent is at the bottom. So this is what we're looking for, that whole thing. Well, this much of it right here, that's half of the whole thing. This much, let's call that X over here. We can find that piece, and then we can double it to get the whole width. All right, so looking here from the 50, opposite and adjacent, that's a tangent. 6.25 over x, so x is 6.25 divided by tangent 50. And that is 5.244. But remember, that's only halfway across. We want all the way across, so we need to double it. So times 2, we have 10.488, 10.489. So the width of the tent is 10.489 feet. All right, that's this one. I hope you got what you needed. If not, send me an email and I will try and answer it via email. Talk to you later. Bye.